Hello, hey guys, Mr. Milton here. Today we're looking at radical equations notes. At the end of this video, you should be able to solve radical equations. You should be able to determine when a radical equation has no solution. Okay, a radical equation is an equation that has a variable inside the radical. Okay, so it's not just an equation that has a radical. It's an equation where the variable is inside the radical. Okay, so it says which of the following is not a radical equation? Out of all these options, you'll notice that B, although it has a radical in it, radical 4, that's just 2. Okay, there's no variable inside the radical, so it's not a radical equation. Okay, to solve a radical equation, you must first get the radical expression by itself on one side of the equal sign. What is the radical expression for each of the following radical equations? Okay, so as we look at A, we're looking for the thing that's underneath the radical, the thing where the variable is underneath the radical. So A is radical x. In order to solve this, we want to get radical x on its side first, by itself. That's what we'd be looking for. B, we'd be looking to get radical 3x minus 5 alone first. Okay? To get these radical expressions by themselves, we need to move the numbers on the outside of the radical to the other side of the equal sign, just like we have been doing when we solve an equation. Okay, so for A, when we had radical 3 radical x plus 8 equals 20, we'd say, okay, let's get this radical by itself. What do we move first? Well, first, we would subtract 8 from both sides. That would give us 3 radical x equals 12. Then what would we do? Well, 3 is still by radical x. It's multiplying, so we need to divide both sides by 3. So we get radical x equals 4. Okay. In B, we'd have 2 radical 3x minus 5 plus 1 equals 15. So our first step here would be to subtract 1 from both sides. So 2 radical 3x minus 5. Subtracting 1 gives us 14. Still want to get the radical by itself, so I divide by 2 here on both sides. And so I get radical 3x minus 5 equals 7. Once you do this, you're still not done with the problem because we don't have the variable by itself yet. The operation that undoes the square root is squaring both sides. Okay, so we're going to solve this equation because we have radical x equals 4. We want to get rid of the square root. We do that by squaring both sides. Cancels out on this side. 4 squared on the other side gives us 16. Okay, up here we had radical 3x minus 5 equals equals 7. We square both sides, and you'll notice on this second problem, when we square it, we're not done. We still don't have x by itself. Right up here we did because x was the only thing under it. But now we don't. So now we still need to solve for x. We add 5 to both sides. We get 3x equals 54. Divide by 3, and we get x equals 118. Okay, so squaring is the new, thing for us here, making sure we get rid of our radicals so we can continue to solve for x. Here's how to solve each radical equation. So number 1, we have radical x plus 7 equals 12. Remember, we want to get the radical by itself first. I want to subtract 7 from both sides. Gives me radical x equals 5. Square both sides. X equals 25. Number 2, getting the radical by itself first. So I'm going to divide both sides by 3 before I start squaring. So radical 2x equals 4. Square both sides. 2x equals 16. Divide both sides by 2. Now, because I need to get x by itself, now that I got rid of the radical, x equals 8. Number 3, you'll notice that our radical is already by itself. There's nothing else on the left side of this equation. So right away, we can square both sides. Okay, so 2x minus 3 equals 49. Add 3 to both sides. 2x equals 52. Divide by 2. X equals 26. want to take the time here to make sure that you see the difference between 1 and 3. Okay, in problem number 1, in problem number 1, we have radical x plus 7, and it's clear, or should be clear, that this plus 7 is not included in our radical. Okay, in number 3, this minus 3 is still covered with our radical sign. So make sure you understand that that's the difference between when it's inside our radical and when it's outside of our radical. Okay, let's go on to number 4. All right, so number 4, we have 3 radical x plus 4 plus 5. Okay, so I'm going to subtract 5 from both sides first. Oops, let me get out of the highlighter. So subtracting 5 from both sides first gives me 3 radical x plus 4 equals 12. Then I'll divide by 3, gives me radical x plus 4 equals 4. Now I have my radical by itself. So I'm going to square both sides to get my numbers outside of the radical, my variable outside of the radical. So I have x plus 4 equals 16. Subtract 4 from both sides, x equals 12. Okay. Number 5, adding 7 to both sides. Excuse me. And so we have radical 5x plus 3 equals 3. Okay. Then I'll square both sides. So 5x plus 3 equals 9. Right, because as we square both sides, this cancels out. Subtract 3 from both sides. 5x equals 6. To get x all the way by itself, I need to divide both sides by 5. So I get x equals 6 over 5. It's a fractional answer, and that's okay. And then number 6, 5 times the radical 3x over 4 minus 1. You'll notice that this minus 1 is outside of our radical. We want to add 1 first to both sides. 5 times radical 3x over 4 equals 15. Divide both sides by 5. So radical 3x over 4 equals 3. Okay. I need to square both sides here to get this variable from underneath the radical. So I have 3x over 4 equals 9. And now I'm multiplying both sides by 4. I get 3x equals 36. Dividing both sides by 3, x equals 12. All right, so a few more problems here. A little tricky here, just talking about a special case. So it says radical x plus 8 equals 5. What would our first step be? Our first step would be to subtract 8 from both sides, right? And so we'd get radical x equals -3. Okay, can you take the square root of any number to get -3? And the answer is no. Okay, we would never say negative. Okay, therefore this problem has no, say, real solution. Okay, if we took the square root of a number, we wouldn't get a negative as our answer. Okay, and so when we have our radical equal a negative number, we'll say no real solution. Okay, when we get the radical by itself, we have to check for this. Does the radical equal a negative number? If the answer is yes, there's no real solution. So number 1, at the beginning of this problem, we see is radical 4x minus 7 equals -5, but our radical is not by itself yet, so we're not going to check if it's possible or anything until we get our radical by itself. So we have 7 to both sides. Now our radical is by itself, and it's a positive number, so we can keep going. 4x equals 4. That must mean that x equals 1. Number 2, there's negative at the beginning, but our radical is not by itself. So until our radical is by itself, we're not checking if our problem is possible or not. Divide both sides by -3. Now my radical is by itself. Radical x plus 1 equals 7. All right, square both sides. x plus 1 equals 49. Subtract 1 from both sides. X equals 48. Number 3. Solving to our radicals by itself. Subtract 6 from both sides. We get negative 2 times radical 2x minus 5 equals 10. Divide by negative 2. Radical 2x minus 5 equals negative 5. Okay, and so now you see a radical equals a negative number. We don't have to go further. No solution. Okay, we don't have to write no real solution, but I do want to say no real solution because in Algebra 2 you'll see that there are solutions. They're just not real. All right, number 4. Notice that we have a radical on both sides. It doesn't kind of feel alone, but on each side the radical is by itself. So we're in space to square both sides. We get 3x plus 4 equals 5x minus 6. Okay, so we'll solve, subtract 3x from both sides, add 6 to both sides, get 2x equals 5, or sorry, 2x equals 10, divide by 2, x equals 5. And you should plug it in to make sure that your number comes out to be a positive number. So that would be 19 equals 19. Okay, radical 19 equals radical 19 works out. Number 5. Okay, this is a tricky problem. Okay, so our first step would be to subtract 8 from both sides because, well, it's positive 8. That leaves us with negative radical 2n equals 12. Okay, don't forget this negative here. It goes with the 2n, not the 8. So now I need to get rid of this before I square both sides. As I divide by 1, I'll get radical 2n equals negative 12. My radicals by itself, it equals a negative number. No real solution. Okay, and then finally we have radical x plus 10 equals radical 6 minus x. Again, square roots are by themselves on each side, so I can square here on both sides. We get x times 10 equals 6 minus x. I'm going to add x to both sides. That gives me 2x plus 10 equals 6. Subtract 10 from both sides. 2x equals negative 4. And then divide by 2, I get x equals negative 2. Now you might be like, oh, negative number, radicals can't work out. But there's no time here that we had to stop. So if you're wondering, hey, does this work out? Plug it back in, see if it works. Okay, as we plug this back in, negative 2 plus 10 is 8. 6 minus negative 2 would be 6 plus 2, 8. Radical 8 equals radical 8. Both positive radicals are positive numbers inside the radical, and so it's equal to each other. Our variable is okay to be a negative. We just can't have a negative underneath our radical once everything's plugged in and simplified. Okay? All right, so there we have it. That is our radicals unit, simplifying radicals, and that was our last topic over solving radical equations. See ya.